It's lesson 37, excuse me. And we are going to continue a topic that we started looking at in lesson 28, which was rational expressions. And then we started looking at it again in lesson 31, where we were multiplying and dividing rational expressions. And today, we are going to start the journey of adding and subtracting rational expressions. On our first day, we are going to look at rational expressions that already have common denominators. So we're going to be able to add and subtract rational expressions with like denominators. And then as we continue our journey tomorrow and Friday, we will be able to add rational expressions with unlike denominators. So first, when we are adding fractions, just a reminder, and we'll just take a look at this problem. If you're adding something like 2/7 plus 4/5, we have to have a common denominator in order to add those. So you could think of both of these fractions as, I always think of pizza. So we have one pizza that's cut up into 7 pieces, and we have another pizza that's cut up into 5 equal pieces. If we wanted to add up the amount that Johnny ate compared to Susie, we can't do that because they're eating different sized pieces. So the first pizza, what's cut up into 7 pieces, they're going to be a little bit smaller pieces than the pieces that are pizzas that's cut up into 5 pieces. So we can't add those together until we would get like denominators, or in the pizza case, the size of the pieces would be identical. Now, to get a common denominator, you are going to look, what is the least common multiple between your two denominators? So to find the least common multiple with numbers, you can just start counting up the multiples: 7, 14, 21, 28, 35. Again, 5, 10, 15, 20, 25, 35. So 35 is going to be that first position that they're going to meet. So that's going to be our common denominator. Then our numerator is going to change in the same ratio as the denominator. So if my denominator I multiplied by 5, my numerator I'm going to multiply by 5. So 2/7 is the same as 10/35. And again, my numerator needs to change in the same ratio as my denominator. My denominator multiplied by 7, numerator multiplies by 7. So I get 28. So I add these two together. Now we're talking about both pizzas in the terms of 35ths. Now I've got 38/35. That's going to be the total amount that Johnny and Susie ate. So they ate a little bit more than one pizza total. So when we're looking at these rational expressions, we have to follow that same idea that we got to have the same denominator, the same sized pieces of pizza in order to combine those together. Once we get the common denominators, then it's just a matter of let's combine our terms in the numerator, and that's going to be our total. You'll notice that your denominator is always going to stay identical. So our denominator just carries along, and that's going to be 35. So today we'll look at example 1 where we have all like denominators. So here first I have a 7/9x plus 10/9x. My answer is also going to be in terms of 9x. So my denominator will be a 9x. And then all I simply do is just add the numerators. So since the denominators are already the same, I don't need to worry about changing the numerators. 7 plus 10 is 17. So 17/9x would be my total. Part B, I've got a 8x over x squared plus x minus 12, and then minus 11 over x squared plus x minus 12. I'm going to rewrite, I'll put the fraction right here. I got to write a little smaller here. But since they have the exact same denominator, I can rewrite that exact denominator. That's going to carry along and be part of my answer. And then in my numerator, I have 8x minus 11, which I can't combine an x and an 11, so this just becomes 8x minus 11. The last thing we would do is we would check for any factoring. 8 and 11 doesn't have anything in common, so I can't factor a GCF out of there. But x squared plus x minus 12, we think about what multiplies to negative 12 adds to 1. That would be x plus 4 and x minus 3. So if we can, we'll get all our polynomials factored. And then we would check to see, are there any common factors with the numerator denominator? No. So this would be our final result. So if we can, we would look for common factors, which we're going to see in Delta Math here in just a second. We'll see how we'll get some common factors factoring out. But here we don't, so we just leave our answer as is. And finally, we have our last problem here, which we've got a 15x squared plus 3x minus x plus 4 plus 10. So we're going to go ahead and start to rewrite that in fraction form. So notice your denominators are all the same, and today we are working with all your denominators will be the same. So we don't have to worry about changing our denominator at all. So there's going to be my answers. Denominator, x squared plus 3x minus 18. Then I check my numerator. I've got 15x squared plus 3x. And there's going to be that binomial. Then I'm subtracting from that x plus 4. Now it's important whenever you're subtracting to put everything you're subtracting into parentheses so that you make sure you subtract both those terms. And then I'm also adding that 10. And since my denominator is already the same, I'm just going to work on the numerator. In my denominator, I look at it does factor because I can multiply to negative 18 and add to 3 by doing x plus 6 and then x minus 3. So there, that would factor. Now in my numerator, 15x squared has nothing to go with. Then I have a 3x minus x, which would be positive 2x. And then this would be a minus 4 plus 10, which would be positive 6. And there I'd have my polynomial in my numerator, and I can already tell that this is not going to factor. So if it does not factor, it's not going to have anything in common with my denominator. So that's going to be then my final result. So there would be my final answer. So in our notes, we would look to factor anything, and we did look to factor anything. So any of these trinomials, x squared plus 3x minus 18, those are going to be the ones that you can factor, and then you can check to see, does it have anything in common with our numerator? So we're going to head to look at Delta Math and look at an example from Delta Math. And thank you. All of you are signed up. I just checked it before class here. You're all signed up. You're all logged into hour 1, so we are all good to go with that. So here we'll look at an example of a rational expression and how we can start to simplify it. So we've got an x squared plus 11x plus 28. Now when you're dealing with a trinomial that's got an a term of 1, this is where we're going to use that little number riddle. So you're thinking to yourself, how could you multiply to 28? So two numbers that multiply to 28, and then those same two numbers would add to 11. Can anybody think of two numbers that would multiply to 28 and add to 11? 4 and 7. So then we're going to have x plus 4, x plus 7. Check your denominator. You have a term of 1 again. So we got x squared plus 10x plus 21. So now you're trying to multiply to 21 and then add to 10. So can we think of anything that multiplies to 21, adds to 10? 3 and 7. So x plus 3, x plus 7. Now here's where it's a little different than our notes. You look at your numerator and denominator. Do you see anything that's exactly the same in your numerator denominator? X plus 7 here, x plus 7 here. So there's going to be our final result. Now when you're putting in your final answer, x plus 4 over x plus 3, you do need to use parentheses so that it groups everything together. Hit x plus 4, then if you hit your fraction bar, which is down by shift, you can then put in your x plus 3 factor, hit submit. There we go. And then there would be our result, x plus 4 over x plus 3. So that brings us to